Hello everyone. In this video we cover the topic minimization of the DFA. So there are the two methods to minimize the DFA. One is the table method and second is the equivalent method. Solve the example using the method which you find the easier out of these two methods. So let's start. So first we see the table method. So for that first we draw here transition table of DFA. Many times instead of this DFA, the transition table is given in the question. Now here the diagram is given, means DFA is drawn. From this we draw the table, but sometimes only table is given, and from this table we minimize the DFA. So state and variable are the A and B. Now initial state is Q0. So Q0, read A in Q1 and read B in Q3. Then Q1 read A in Q2 and B read in Q4. Then Q2, Q3 and Q4. Q2 read A in Q1 and Q2 read B in Q4. Now Q3 read A in Q2 and B in Q4. Now Q4 read A in Q4 and Q4 read B in Q4. This is our final state. Now draw the table. How we draw? Here we draw. So first in the column the initial state is not considered. So here we draw Q1, Q2, Q3 and Q4 because Q0 is the initial and here final state is not considered. So here Q0, Q1, Q2 and Q3. We not consider here Q4. Now draw the table. Now so we draw the table. Now Q4 is the final state, so cross all the row of the Q4. So meaning of this is this final state and the initial state, final state and Q1 state, means here 1 is the acceptance state, this is the acceptance state and this is not acceptance state. And when 1 is, let's suppose P is the acceptance state and Q is not the acceptance state, so these are the Q and Q are not the acceptance state. That time this is the distinguishable state, distinguishable. So these are the distinguishable, and if P is also acceptance and Q is also acceptance, then this is indistinguishable. So I hope all you get idea. We cross all the Q4. Now we write the pair. So how we write the pair? First start from this Q0 and Q1. So Q0, Q1, then Q0 pair with all the remaining state. So Q0, Q1, Q0, Q2, Q0, Q3, Q0, Q4. Now start from the Q1. First we start from Q0, then we pair with Q1. Now we start from Q1. So Q1, Q2. So Q1, Q2, Q1, Q3, Q1, Q4. Now this we start from this Q2. So Q2, Q3, Q2, Q4. Now Q3, Q4 is Q3 and Q4. I hope all you get idea. Now we cross this state, Q0, Q4, Q1, Q4, Q2, Q4 and Q3, Q4. This column we cross. So not consider this state, only consider these pairs. So one more table we draw here. So right now remaining all the state. So Q0, Q1, Q0, Q2, Q0, Q3, then Q1, Q2, Q1, Q2, Q1, Q3 and Q2, Q3. Now this Q3 and Q4 we cross. So crossed pair not consider. Now again same procedure, consider here A, consider here B and see the transaction. So Q0 and Q1 read A, Q0 and Q1 read A in Q1 and Q2, Q1 and Q2. So this Q1, Q0, Q0, Q0 always read A in Q1 because Q0 read A in Q1. So quickly we write here Q1, Q1, Q1 because in exam we solve the example quickly because time is limited. So quickly here write Q1, Q1, Q1 because this change is not state is not changed. Always Q0 read A in Q1. So quickly write here Q1. Then Q1 read A in Q2. Then this Q2 read A in Q1 and Q3 read A in Q2. So we write here this Q2 read Q1 and Q3 read A in Q2. Same for B. So Q0 read B in Q3. So Q3, Q3, Q3 because in limited time we solve the number of the questions. So we do all the process fast. Now Q1 read B in Q4. This Q2 also read B in Q4, Q4 and Q4. So we write here pair. Now Q1 and Q2. Q1 read A in Q2. Here is also Q1. So we write here Q2. Then Q2 read A in Q1 and Q3 read A in Q2. So Q1 and Q2. Now B. Q1 read B in Q4. So Q4 and Q2 read B in Q4. Q3 read B in Q4. I hope all you get idea what we do here. Now Q2, Q3. So Q2 read A in Q1 and Q3 read A in Q2. So Q1, Q2 and Q2 read B in Q4. Q3 read B in Q4. So Q4. Now our table is finished. Then we cross again the distinguishable pair. So distinguishable pair means one is acceptance, another is not acceptance. So we see Q4 is our acceptance. So only single Q4 where we cross this state. So we see here in this first pair Q4 is present in B. So we cross it. Then again Q1, Q3, Q4. So single Q4 is present, cross. Single Q4 is present, cross. Single Q4. If double Q4 is come, then not cross this state because this is indistinguishable. We only want to cross distinguishable, not indistinguishable. So Q4 will not cross. Here is also no any Q4 is single Q4 is present. So from this we draw the review table. So here review table. In this review table, which state we not cross, write all this state. So Q1, Q2 we not cross, so we write. Then Q1 Q3 and this Q2 Q3, Q2 Q3. Here is A, here is B. Write all this state also as it is. So Q2 Q1 Q4 Q4, Q2 Q2 Q4 Q4, Q1 Q2 Q4 Q4. Then again check, is any pair we cross or not, because from this any single Q4 is present. Here is Q4, so any single Q4 is present, or any state which are we here cross, but here we write means Q not Q1. Is any Q not Q1 is present in this state? No. Then Q not Q2 is present? No. Q not Q3 is present in this any state? No. If any state is present here, let's suppose here is Q2 instead of this Q not Q2 is present, then from this review table again we cross this state, because here is the one state which we cross already. So this whole state is cancel and only two state we write again in the review table, but here no any state again we cross. So this is our final review table. Now from this we write distinguishable and indistinguishable state. So distinguishable and here is indistinguishable, or here we write indistinguishable. So indistinguishable means which state are present in this delta. Here is the delta, so these are the state and these are the transaction. So which state are present in this table, these are the indistinguishable. So Q1 Q2, this is the one pair, Q1 Q3 is one pair and Q2 Q3 pair. But if we do here intersection, then the Q1 is common in these two state, and in this two state Q3 is the common, and from this two Q2 is common. So instead of write again this two pair, we form one pair which is Q1 Q2 Q3. But if any condition means no any common present in between two state, that time we write this one pair separate, this one pair is separate, and this one pair is separate. But now the common is present, so we write commonly Q1 Q2 Q3. And now which are the not present in indistinguishable, these are the distinguishable state. So distinguishable state are Q0, then Q1 is present, Q2 present, Q3 present, Q4. So this is the indistinguishable. So now from this we start to draw our final minimization DFA. So as it is, we start from the Q0, because Q0 is our initial state. So first we write here Q0. Q0 is our initial state. Now we draw the minimization DFA. So Q0, then Q0 read A in Q1, but the Q1 is pair with the Q2 and Q3. So this now Q1 we not write separately, we write in the common this Q1, Q2 and Q3, because now this Q1 is paired with Q2 and Q3. So here A is read. Now Q0 read B in Q3, then again Q3 is present here in this state. So here A comma B, Q0 read A comma B in this single state Q1 Q2 Q3, because A read in Q1, so Q1 is present, and B read in Q3, so Q3 is also present. Now for if this is the we think this is the hardest process, then again we draw one transaction table. So first we write all the transaction and then draw this DFA, then this is also simple one. So now I draw here first delta A and B. So I start from Q0. So Q0 read A, B, C in Q1, Q2, Q3. Now B is also right in Q1, Q2, Q3. We see because B read in Q3 and Q3 is paired with Q1, Q2. Now this state we assume as our single state. We know, I hope you all know how we draw this table, DFA table. So now we consider this state Q1, Q2, Q3. Now Q1 read A in Q2 and Q2 is paired with Q1, Q2, Q3. So Q1, Q2, Q3 and Q1 read B in Q2 read B in Q4, but Q4 is not in pair. These are the separate. Q0 is separate, Q4 is separate. So we write here Q4. Now we check second state. So we consider this always initially. Now Q1, Q2, Q3 also we consider here. Now Q4 is the state which is we not consider. So we consider this Q4. So Q4 read A and B in Q4. So Q4 read A in Q4 and Q4 read Q4. Now any state is remaining which is we not consider as a state? No. So these are the final transaction, minimization transaction table of the DFA. So from this we draw this DFA. So Q0 read A and B in Q1, Q2, Q3. Q1, Q2, Q3 read A in Q1, Q2, Q3 itself. A and B read in Q4. So let's suppose here is the Q4. Now Q4 read A and B itself. So here A and B. So this is the minimization of the DFA. This is the original DFA. Now this DFA we minimize in this diagram. So I hope you all get an idea how we minimize the DFA. We see one more method to minimize this DFA. Now if we see, then it take whole one page to solve and it is something time consuming process. So one more method is which only 2 to 3 steps we minimize the DFA, and this is the faster process which we see now. Instead of doing this lengthy process, first start with the grouping. So final state is one group and which is not final or the acceptance state, these are the separate. So one group is Q4. So we draw here, write here one group of the acceptance state which is Q4 and remaining all state in another group. So second group is Q0, Q1, Q2 and Q3. So Q0, Q1, Q2, Q3. This is the zeroth equivalent. This is the method number 2. Method 2. You solve by using this method all the previous method number 1. So we here find out the zeroth equivalent. This is the acceptance state and this is the non-acceptance state. Now we find out first equivalent. Now this Q4 is the single, so we not disturb this Q4, and these are the 4 elements in one group. So we split this 4 element. How? First we see Q0 in Q1, Q0 in Q2, Q0 and Q3 in this pair. So first pair is Q0 and Q1. So Q0, instead of refer this diagram, we refer this transaction table. So this Q0 read A in Q1 and Q1 read A in Q2. This A is read in Q1 and Q2, and Q1 and Q2 are present in one group. So Q0 and Q1 is also present in one group in first equivalent. But we check B also. So Q0 read B in Q4, Q1 read B in Q4. So Q3 and Q4 are not present in same group. So from this we say Q1 and Q3 are the separate group, because A is read in same group but B is read in separate two groups. So this Q1 and Q3 we write, Q3 no, Q0 and Q1. Q0 and Q1, because we see the transaction of Q0 and Q1. So Q0 and Q1 is in same group, because A read in the same group but B read in the separate group, which is one is present in Q3 in one group and Q4 in second group. Now Q0 and Q2, same procedure, Q0 and Q2. So Q0 read A in Q1 and Q2 also read A in Q1. So Q1 present in the one single group. Now Q3 and Q4. Q0 read B in Q3 and Q2 read B in Q4. So Q3 and Q4 are in separate two groups. So this Q2 is also now not in the Q0 group. This is the separate Q2. Now Q0 and Q3. Q0 read A in Q1, Q3 read A in Q2. So this Q1 and Q2 are present in the same group. But if we see the B, then B read this Q0 in Q3 and Q3 read B in Q4. So Q3 and Q4 are present in two separate groups. So this Q3 is also now separate. So these are the in one group and Q0 is present in one group. Now we find out second equivalent. So this second equivalent, now Q0 is single element, we not split again. So this Q0 write as it is, this Q4 write as it is, and now same procedure follow for this three element, because these are the in one group. Now same, here we pair this Q0 with Q1, Q2, Q3 separately. Now this Q1 pair with Q2, Q1 pair with Q3. So Q1 and Q2. Q1 read A in Q2, Q2 read A in Q1, and now this state check in previous state, means now second equivalent we refer the first equivalent. First equivalent we take reference of the zeroth equivalent. Now these are the group, not consider this zeroth equivalent. So this Q1 and Q2, Q1 read 2 in Q2 and Q2 read A in Q1, and these are the present in a single group. So these are the present in one group. Now we check B also. Is B separate these two state or not? So Q1 read B in Q4, Q2 read B in Q4. So Q4 present in a single group. So this Q1 and Q2 is present in a one group, because both A and B read in the same group, Q1 and Q2. Now we see, is Q3 is also present in same group or a different group? So Q1 and Q3. So A read in Q2 and Q3 also read A in Q2. So Q2 present in a single group. So A is follow. Now we check B is follow or not. So Q1 read B in Q4, Q3 read B in Q4. So Q4 and Q4 also present in a one single separate group. So this Q3 is also paired with this Q1, Q2, Q3. So these two state we get same. Follow the procedure where if we get two equivalent are the same, then that condition we stop. So here is also one group Q0 is present, here is also Q0 is present. Q1, Q2, Q3, this one group is present in first equivalent also and second equivalent also, and Q4 and Q4. So these are the equal, so we stop here, and these are our final group. Now we start to draw the DFA. Now we see here q naught is our initial state, so we start with this q naught. So q naught is the initial state. Q naught read q1, a read in q1, so q1 is paired with q1, q2, q3. So q1, q2, q3, this is the one transaction of the a. And q naught read b in q3, and q3 is also paired with this q1, q2, q3, so this is the b. If you check this q2 and q3, then again we the same transaction. Now this q1 read a in q2, which is present in itself. So 1 minute, here we first see the q naught. So q naught read a in q1, and q1 is paired with q2 and q3, so this state we draw here. And q naught read b in q3, and q3 is also part of this group, so here a and b, we check the transaction of q1, q naught. Now we check for this state. So q1 read a in q2, so this is the read by itself because q2 is paired with q1, q2 and q3. And q1 read b in q4, so this state is q4 and read here b. If you check this q2 also, then again we get same condition. See, q2 read a in q1, so q1 is also present here, so we draw here this a read by this state itself. And q2 read b in q4, so which we draw here already. So q3 also follow the same rule. q3 read a in q2, q2 is present here, so a. q3 read q4, b in q4 we draw here already. So q4 read a and b itself, a and. So we see here which we draw here previously by using the table method. Same we draw the transaction here, q naught, this pair, and q4. So from this 4 line of the solution we draw this transaction, and previously we cover whole one page, and then we got this DFA. So now choice is yours which method you want to follow, but I think I go through this method number 2 because this is the not time consuming process. From only half of the page we get the answer. So by using this method number 2, we solve one more example. So this is our example. Here instead of the diagram we have transaction table. So from this we draw the minimization DFA. How, let's we see. So as it is, collect acceptance state in one group and non-acceptance state in another group. So here only one single C state is the acceptance, so here C is separate acceptance state, and remaining all A, B, C, D up to H in one group. So A, B, C, D, E, F. This C is not here because C is present in another group. E, F, G and H. So this in zeroth equivalent only 2 groups are present. Now we draw the first equivalent. So in first equivalent we check one by one pairs. First pair with A. So first we check A and B. So A read 0 in B and B read 0 in G. So this first transaction is present in a single group, so it is okay. Now we check second 1. So 1 read A in F, B read in C. So this F in one group and C is the another group. So this A and B is not equivalent, means not equal. So we write A in separate group and B is in separate group. This C is one group because this is the single element. We not divide this single element. So A and B is the not in the same group because here 0 read in same group but 1 read in the separate group. So this A and B is now separate group. Now A and D. So A read 0 in B and D read 0 in C. So B and C. B is present in one group and C present in another group. So again this A and D is not present in the same group, because initially we see here A read 0 in B and D read 0 in C. So this FG is present in same group. A read 1 in F and D read 1 in G. So these two elements F and G present in single group, but initially it not read in same group. So we write separately. Here is the D, not C. D. So A and D is not present in the same group. Now A and E. So A and E. So A read 0 in B, E read 0 in H. So B and H. So B is present, H is present. So both are the same group. We see transaction of 1 also. So A read 1 in F, E read 1 in F. So FF also present in the same group. So this A and E now present in the same group because both are the equivalent. A also read 0 in the same group and B also 1 is also read in the same group. So A and E is pair. Now A and F. A and F. A read 0 in B, F read 0 in C. So B and C. B is separate group, C is separate group. So these are also now not with same group. So F is added here. Now G. A and G. A read 0 in B, G read 0 in G. A read 0 in B and G read 0 in G. So B and G. So B and G present in the same group. So 0 is satisfied. Now 1. A read 1 in F, G read 1 in E, and F and E both are in the same group in 0th equivalent. So again this G is added here because these A and G are the equivalent. Now H. A read B 0 in B, H read 0 in G. So B and G present in the same group. Now A read 1 in F, H read 1 in C. So F and C are present in two separate groups. So we write this H separate from this one. So this is the one group and now this is the one group. So this is the first. Now we find out the second equivalent. Now here one group is AEG, second is ADFG, and this C is the separate. So we not write any condition for this C because this is the single element. So we write as it is. Now we see these two groups. So we again as it is. We see A in E. So A and E. A read 0 in B and E read 0 in H. Now B and H present in first equivalent, present in same group or not. So A and E read B and H. So B is in here and H is also here. So these are the present in the same group. So A and E we write together. No, first we see 1 also because only 0 is not enough. We see 1 also. So A read 1 in F and E read 1 in F. So F is also present in the same group. So now we write here A and E. We check both the transactions 0 and 1. And if these two are present in the same group, then they are present in the same group. Otherwise they are separate group. So A and G. A is present in read 0 in B and G read 0 in G. So B and G. So B here and G is here. So these are two present in the separate group. Now we not check this 0th equivalent. We check first equivalent because we want to find out group for the second equivalent. So we check previous group. So B and G are present in the same different group. So this G is not group in A. These are the separate group. So this A and E now present in the one group and G is present in the different group. Now this B and D. we not check now G, because G is the single element which are present in the different group. We not add this G in this group also, these are the separate. Now B and D, we start the second group, B and D. So B read 0 in G and D read 0 in C. So G and C. So in first equivalent, G is present in separate group and C is present in the separate group. So B and D is not now not in same group. So B is one group and D has separate group. So B and D we write separately. Now B and F. B and F. B read 0 in G and F read 0 in C. So G and C, again this is the separate group. So F is now in D group. F. Now B and H. B read 0 in G, H read 0 in G. So G is separate, present in the single group. G, here is the single G. Now we see 1 also. B read 1 in C, G read H read 1 in C. So C and C again present in the single one group. So B and H is in one group, and now D and F is the separate group. Now third equivalent, again the same procedure, follow this same procedure until we not get this same two equivalent. Now A and E. So A and E. So A read 0 in B, E read 0 in H, and B and H are present in the same group. Yes, B and H present in the same group. Now 1. A read 1 in F and E read 1 in F. So F and F is also present in the same group. So AE is in same group. Now G is the single, write as it is. Now BH. B read 0 in G, H read 0 in G. So G and G present in the single group. So this BH is also in same group. Now DF. No, we see only 0th transaction. We see 1 transaction also for the BH. So B read 1 in C, H read 1 in C. So this is in same group. So write as it is group. Now DF. D read 0 in C and F read 0 in C. So C and C again in same group. We check 1 also. D read 1 in G, F read 1 in G. So this D and F is in same group because G is also present in a single group. Now C is the single, so write as it is. Now we get two equivalent are the equal, same. Here is the A, here is also A, G, G, BH, BH, DF, DF, C, C. So now our transaction is over. Equivalent we not found or solve the further, we stop here. Now only we draw the transaction. So we start with the A because A is the initial state. So we start with initial state A, but A is not present single. This is the pair with E. So we write here A, E. And this is the one state. Now A read 0 in B. So B is pair with H. So we write here BH. B and H. We write all the pair. And here it is read A. Now A read B. A read B in F. And F is the pair with D. So D and F read 1. So we write here this read 0 and this read 1. D F. Now we complete this AE, and if we check this E also, then again we got same. See, E read 0 in H and H is present here. E read 1 in F, F is also here present. Now BH. B read 0 in G. B read 0 in G. G is the single state. Now B read 1 in C. So we write here C. Read 1. If we check H, then this is also H read 0 in G. We draw here. And H read 1 in C. We draw here. Now this G. G read 0 in G. 0. And G read 1 in E. So E. E is the pair with A. So we draw here one transaction 1. So we cover this 0 and 1 for G also. Here is also 1 and 0 is cover, 1 and 0 is cover. Now these two transaction which we not cover, 1 and 0 both variable. So DF. D read 0 in C. So C is the single state. So we draw here 0 and D read 1 in G. So here 1. F also read 0 in C and F read 1 in G. So we draw here already. Now C. C read 0 in A. So we draw here 0 in A. Now C read 1 in C itself. So we draw here 1. Now we complete all these state and both variable also for each state. So this is our final minimization DFA. If we see, then here number of variable this state is 1, 2, 3, 4, 5, 6, 7, 8. 8 number of state are present, but here now in minimization only 1, 2, 3, 4 and 5. 5 state are the present. So this is the minimization of the DFA. And now C is the acceptance state. So draw here acceptance state. A is the initial, A is the initial. So this is the final minimization DFA. We solve only half of the page. We find out the final minimization DFA. If you want this same equation or same question with the table method, then it takes 2 to 3 pages to solve. Here all we see, these are the pairing, this is the question, and by using this table method, here is the final answer which we draw in only half of the page. So total 3 pages it takes if you go through the table method, but by using this second equivalent method, only half of the page we get this final answer. So I hope all you get idea now. If any question or query, then let me know in the comment box. Thank you.